Lesson 6.2, the natural base E. Our essential question, how do you define, use, and graph natural base E? So we know pi represents a certain value, and we know I represents a certain value. We are now being introduced to the letter E, which we call natural base E. It also represents a particular value. So this red line right here, because E is a value, represents the value E. And we have this expression right here that if you had x as 1, and as x gradually got larger, if you use 2 or 3, it got ever so closer to the value of E. So if you used x to be the largest number you could possibly think of, you would be as close to E as you could possibly get. So as we get closer and closer, E starts kind of looking like this, and we're going to start playing with the value of E. When you have a function of the form y equals a value a times e to the rx, this is called the natural base exponential function. A is always going to be bigger than 0, meaning a always needs to be a positive number. R is either going to be bigger or less than 0. So R, the rate, is either going to be a positive or a negative number. Whether it's positive or negative will tell us whether we are doing exponential growth or exponential decay. If we are growing, our R is going to be bigger than 0, meaning R is going to be a positive number. If we are decaying, our R is going to be smaller than 0, meaning our R is going to be a negative number. Exponential growth functions grow as you read from left to right. Your exponential decay functions decay as you read them from left to right. Let's look at our first problem. Tell whether each function represents an exponential growth or an exponential decay. Looking at our problem, this is the natural base E exponential function. So how we tell if this is going to be a growth or decay is all based on R. We need to identify R. How do you identify R? You look to see what value x is being multiplied to. So our exponent x is being multiplied to a value of 1. 1, I know, is bigger than 0, which meant this is going to be an exponential growth function. So we determined it was exponential growth. Now it wants us to graph the function and then identify the domain and the range. To graph the function, we are going to use a table of values. We have a graph right here, and we're going to use a few negative x values and a few positive x values. So if I type negative 2 into this function, I get 0.41. Negative 1 into this function, I get 1.10. 0 into this function, I get 3. 1 into this function, I get 8.15. 2 into this function, I get 22.167. So a couple of negatives and a couple of positives, which means this xy axis is not going to be working for us. So we need to make our new xy axis. So I'm going to use a marker. This is my new y-axis, and I'm going to keep the x-axis. So we're going to go ahead and scale, and we're going to plot our points. And so it ended up looking like this. I see it is going up as we read from left to right, so this is an exponential growth function as we had predicted. Now I need to identify my domain and my range. So remember, our domain looks at our x values. How far to the left and how far to the right will this function go? This arrow says I'm going to be forever going to the left, and this arrow says I'm forever going to the right. So that means my domain is going to be all real numbers. And remember, your range looks at your y values. So what's the lowest y value used? I can see that this is getting closer and closer and closer to the x-axis. It will never pass the x-axis. So that means this x-axis right here is the lowest that this is going to go. That is the y value of 0, which means that our range says I'm never going to dip below the x-axis, which means my range is going to be greater than 0. It's going to get so close to 0, you're going to think it's 0, but it's actually not going to hit 0. It's going to be everything bigger than the 0 value. Looking at our next question, tell whether the function represents exponential growth or decay. To see if we are growth or decay, we need to look at our R value. The R value is what your exponent x is being multiplied to. So my R value is a negative 0.05. which I know that this number is actually smaller than 0. If you're smaller than 0, then you are in exponential decay. Next, we're asked to graph it. We're graphing it using our table of values. We're going to use a few negatives and a few positives. Type in -2 into this function. I end up getting 2.71. -1 into this function, I get 1.64. 0 into this function, I get 1. 1 into this function, I get 0.60. And 2 into this function, I get 0.36. So I used a couple of negatives and positives, which means this XY graph is not accurate. I need to make a new XY graph. And I'm going to scale it. And graphing our points. Started high and it's getting low, which is representative of exponential decay, just like we thought it would. So now we are going to look at our domain and we're going to look at our range. Domain looks at your x values. How far to the left and how far to the right will this continue to go? I see that this arrow is going to go forever to the left and this arrow says forever to the right. So I'm using all my x values, which means my domain is going to be all real numbers. Now what about my range? My range represents the y values. I see that this is getting forever closer and closer and closer to this y value of 0, but it's never actually going to touch the y value of 0. So it's going to be everybody above it. So y is greater than 0 is going to be our range. It'll always be up here, but it's never actually going to touch the 0. So looking at our last problem, we are supposed to tell whether we are at exponential growth or an exponential decay. We do that by looking at our r value. The r value is the number that the x exponent is being multiplied by. The number multiplied to this x value is a 1. Since that is greater than 0, we know that this is going to be an exponential growth. Now we are being asked to graph. If you are going to graph it, we are going to use a set of XY table values. We're going to do a few negatives and a few positives. Plugging -2 into this function, I get 0.009. -1 into this function, I get 0.06. 0 into this function, I get 0.5. 1 into this function, I get 3.6. 2 into this function, I get 27.2. I see it started small, and I see I'm getting increasingly larger, which is representative of exponential growth. Because I use some negative x values, this xy axis is no longer appropriate. I am going to redraw an xy axis in the center so I can focus on all the positive and negative x values. I am going to rescale -2 and 2, and 27 is way off. So we started very, very close to 0, and then it just skyrocketed. So we are looking now at our domain and our range. Domain is your x's. I see that it started really, really close over here, and it's always going to the left. And I see this arrow says always to the right. So my domain is going to be all real numbers. Range. Ranges are y values. I see that this side is getting closer and closer and closer to this y value of 0, but it's never going to cross that y value of 0. And then it's going to keep going up. So we need also close to 0, but always bigger than 0. So we are going to be as close to, but not actually 0, and then everything bigger. The next 2 pages are independent practice. Please take a look at those.